Hello everyone and welcome to the InSciLabTech community. I'm Dr. Ranjana Verma, a research consultant at InSciLabTech. As part of our For Researchers by Researchers initiative, I'm here to show you how to do FTIR analysis of graphene oxide using OriginPro. In this tutorial, we will start with the raw FTIR data of graphene oxide, clean the baseline, smooth the spectrum, identify and label the characteristic functional groups, and finally prepare the publication-ready plots. Let's begin by importing the FTIR data. Open your Origin software. Go to the file, import single ASCII. Select your CSV data and open it. So this is my wave number versus transmission data. You can plot and check it. Now the baseline is not correctly aligned in this, so I need to apply the baseline correction and smoothing this data. Now, however, since my data is percent transmission, I cannot apply a baseline correction directly, as percent transmission is not a linear quantity. So I need to convert percent transmission to absorbance, which is linear and additive quantity. If I apply baseline correction directly to percent transmission, then my peak shape becomes distorted. So always convert percent transmission to absorbance for baseline correction. So how to do that? We need to create a new column, and in the formula box type the conversion formula. So go to your Origin software, go to your data, add a new column. In the formula box, you can type the conversion formula, that is log 100 divided by your percent transmission column, which is column B. You can type column B whole text or just B, both are recognized by the Origin software. Once you hit enter, the percent transmission converted to absorbance data. You can plot and check that. Now I want to apply the baseline correction. So go to the analysis, pick some baseline, pick analyzer, open dialog box. Now my goal is to create baseline and subtract baseline. So select that, go to the next. I want to create a realistic baseline, so select the user define. In user define, we have the automatically created some anchor points which are present on the non-absorbing region of your spectra. If you want, you can modify or update or add more anchor points. To do those, click on the uncheck the enable auto, and you can add more anchor points or modify and delete the anchor points. So to modify and delete, select the anchor points and using the mouse and drag to a new location where you want to place it. Once you feel like that all anchor points are correctly placed on non-absorbing region, then select done. Go to next and finish. So a realistic baseline has been created and subtracted from your absorbance data, which is presented as a new column. So this is the subtracted absorbance data. I don't want the baseline, so I'll remove it, delete it, select remove, so that only the selected column has been deleted. So now let's plot and check. When I plot, what I see that my absorbance has some negative values. This means that while creating the baseline, the baseline was placed too high. And if I convert back this absorbance value, my percent transmission may exceed more than 100%. So I need to fix this negative absorbance issue. So there are two scientific methods to do this: subtract a straight line from the baseline so that your baseline is shifted positively to get the correct positive absorbance. In the second method, we can add a constant offset, that is, we need to find the minimum absorbance value and shift the entire spectrum upward so that minimum becomes 0. So today I will show you the second method. Go to your Origin software. This is your negative absorbance data. Go to the analysis, pick from baseline, pick analyzer, open dialog box. Now this time will subtract the baseline, which is a constant value, and this constant value is a minimum absorbance. Y-axis is your absorbance, so that means that you are subtracting the minimum absorbance value. So click on next and finish. Now in your data, a constant absorbance, which is minimum absorbance, is been subtracted. This is the baseline data. I don't want, so let's delete it. This is the subtracted absorbance data with positive absorbance values. Now I want to convert back to transmission. So the formula is percent transmission equal to 100 into 10 raised to minus absorbance. So let's go to the origin. In your data, add a new column, and in the formula box you can type the conversion formula, that is 100 into 10 to the power minus of your correct absorbance, that is column G. With enter. So this is your percent transmission data. You can plot and check. So this is correct percent transmission. I want to apply some smoothing. So go to the analysis tab, signal processing, smoothing, open dialog box. Now here in the method, we generally use the Savitzky Golay method, which preserves the true shape of the peaks and widely using spectroscopy to reduce the noise. In the point window, you can select any points between 10 to 20 as per the noise present in your signal. You can auto preview in the adjacent window. Once done, select OK. Your smoothing curve is overlap on the original data, and the data is created as a new column. This is your final transmission data. So I'll this a sample name. In the comment I'll write down percent. So this is my final corrected percent transmission with baseline correction and smoothing applied. So let's plot this using the line plot. Now in FTIR, absorbance are written from higher to lower energy values. So double click on it. Go to the scale. In the from, type the higher wave number value, and in the to, type the lower wave number value and apply. So your wave numbers are placed in the reverse direction. For presentation purpose, I draw the top and right side line. So go to the lines and text. Go to the top, show lines and text. In major and minor axis, I don't want any tick, so select the null, apply. Do the same for the right side. Show lines and text. In the style of major and minor axis, select null, apply, OK. I don't want this to be written. The text toolbar, select and click on the plot region. You can type this sample name. This is Graphene Oxide. You can rename the y-axis, which is percentage. You can rename the x-axis, which is wave number. Unit is centimeter minus 1. Minus 1 is superscript. Select and use the superscript. You can increase the thickness of the line. Select and increase the thickness. Click here. Now to label, I'll use an arrow to highlight the peak position, and using the toolbox you can write down the peak. So at about 3400 OH stretching bond is present. So I'll write down that. You can increase or decrease the font size. Select it, and the font size you can increase or decrease it. Do this for all the peaks present in your spectra. This is my double bond O. carefully. And increase the font size to 16. Okay. So do for all the pics. Once done, go to the file, export graph. In the file image type, select the PNG, write down the file name, select the file location where you want to save this data, and check that your DPI is at least 300 resolution. Click OK. Your plot will be saved as an image file which you can use in your research paper, thesis, or any presentation. I hope this tutorial was helpful for your research. To continue the conversation, ask questions, or collaborate with fellow scientists, please join our community hub at InSciLabTech. The link is in the video description. We would also love to hear your feedback directly. Let us know what you think in the comments. Thanks for watching.